Welcome to Truth Tables video. It's about logical equivalence, tautology, and contradiction. Let's discuss first contradiction. A contradiction is when all your final entries, all the results at the last column of your table are all false. Okay. For example, in this truth table, you will see at the last column, it's false and false. Okay, so a contradiction is a compound preposition that is always false. Okay, so in here, in this truth table, we use and as an example. Okay. The next one is tautology. Okay, again, in this table, I use a proposition, just one proposition, P, and then I negated the proposition P. So if your proposition is true, when you negate it, it becomes false. And then when your first statement is false, when you negate it, it becomes true. This symbol refers to inclusive OR. So when you have a true or false situation, you get a true value. And then when it's false or true, okay, your compound statement is true. So in this case, all your final entries are true. So then it's a tautology. So this is the opposite of contradiction. This time, your compound proposition's value will always be true. Okay. Now let's talk about logically equivalent. If it's logically equivalent, you're going to use this symbol with two arrowheads, and it will be read as if and only if. Okay, let's have one example for logically equivalent. Okay, given compound statements, you have your first proposition, the values of your first proposition are in the first column, and then the values of your Q statements are on the second column. Okay, if we use a OR, okay, inclusive OR, so we talked about the values of inclusive OR, and it will only become false when you have a false and false statement. So you have all this true, 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 and then false. At the last column, we negate the values here in this column of P or Q. Okay, so the negation of true is false, true is false, true is false, and then at the last one, false, it becomes true. Okay, on the next compound statements, okay, we negated the original proposition. So negate P, you will have F here. You negate this false, it becomes true, so on and so forth. So all of these are negation of proposition P. The same with Q. Okay, we just negated the proposition Q, and all the values here are just the opposite of the values that you have here in Q. Now this time we're going to use AND. Okay, so F and F is false. True and false is also false. And then false and true is false. And then true and true is true. As you have learned before, for AND, it only becomes true when both of the statements are true. Okay, so now let's take a look at the final entries of your tables. Both final entries of both tables 1 and 2 have the same values. Okay, so that whenever you have the same values at the last entry or the last column, you can say or you can make a deduction that they are logically equivalent. Okay, so the compound statements, the negation of P and Q, and the negation of P or negation of Q have the same truth values. So therefore, they are logically equivalent, and you can say that the negation of P and Q, or sorry, if the negation of P and Q, then the negation of P or negation of Q. Okay, so let's use an example here. Okay. Construct the truth table for the statements. You're given these statements. Okay, so here's an and situation. This is inclusive or, and then and. Okay, so here are the given values. Let's do, this is and true is true. Okay, true and false here is going to be false. Okay, false and true is false, and then false and false, false. Okay, now we're going to negate the values of these values according to these symbols. Okay, so we just get the opposite. Your true becomes false, your false becomes true, another false is true, and then your false true. Okay, now let's move on to the next column. This is inclusive or. Okay, inclusive or is true when you have, okay, true and false, false and true, and then true. Okay, so let's check. True and true is, we're comparing these two columns. True and true is true. Okay, true and false, I made the summary before we began putting the values. That's true. And then false and true is true. And then false and false is false. Okay, now in here, in this symbol, we're going to negate these values. Okay, so that will become false, and then this one will become false, this one will become false, this is true. Okay, now this is now a longer compound statement, but this compound statement, we already have this value. This represents, okay, this column, so our values are here. Okay, now our Q is over here, so we are comparing red to red. Okay, we are doing it in an inclusive or. Okay, so different values, true and false. If you remember, it's true. Now false and true, or true or false, sorry, we're using this first. True and false is again true. True and true is also true. True and false is true. Okay, now the last column, this symbol of the negation of P or Q, we already have the values here for this one. This is this column, and we are comparing it to P, which is the first one. Okay, so we want this column and then the first column. So false and true is false. False and true, which is the same case as the first one, so this is also false. Then false and false or false. No, I'm right. False and false, it's false. Then you have true and false, it's false. Okay, now if you take a look at the right, written in red here, they are all true, so we can now say and make the deduction that the negation of P and Q or Q is a tautology because they are all true. Okay, on the last column, at the last column, we have false, so we can make a deduction. Okay, for the negation of P or Q and P, okay, it's a contradiction. Okay, I hope it's clear. If not, it will help you if you watch this video again and try to make the truth value on your own. Construct the true value and put the truth values in it on your own, so you can practice. Okay. You may check your understanding by solving number 2, letters B and C, and number 4, letters D and E on page 397. We'll check your solution when I see you in class.